My name is Jacques Cohen, and I'm co-moderating this session with Professors Allan Pacey and Professor Harry Fisch. And we're talking today we're discussing the very urgent topic of potentially decreasing fertility. The findings so far particularly emphasizing male reproductive health and sexuality. The first reports about decreasing sperm counts are really decades old. Even Harry Fisch published a paper on this in 1996. So we'll go way back. I think it goes back further than that. So this is a known topic, and it's becoming more and more urgent as the papers are published. It was sometimes postulated that this phenomenon was artificial for technical reasons, but we have gotten kind of over that and moved on. Those days seem to be in the past. Sperm count assessments have been well controlled from a methodological point of view, at least in the last 15 or 20 years. And the decrease in sperm count seems to be continuing. Other areas of major concern are, of course, endocrine disruptors. We've had a session in the past about it in female fertility. This session is not just about whether these findings should alert us. Of course they do. Whether they should alert us or not. Maybe some people are not concerned, but we should also talk about possible countermeasures. And I think the speakers will go over this today. We should talk about how to have a healthy life and a healthy home, healthy workplace. The question we are asking today is whether the effects we see are real, whether this is an endgame scenario, and if so, what we can do about it. Now, this session today is sponsored by our cold sponsor, Zymote, and we're very grateful for their contribution. My co-hosts today are male reproductive wizards, Professor Pacey and Fisch. Allan Pacey is coming to us from Sheffield. I think that's in Northern England. And Harry is from Miami in Florida, which is, of course, on this side of the ocean. Both are strongly academic. They're both visionaries and among the best communicators in the field of male reproduction. They have hosted many radio and TV shows. And I really could not ask for a more talented team of moderators. Allan is professor of andrology in the Department of Oncology and Metabolism at the University of Sheffield. His research interests include aspects of male fertility, of course. He has published over 200 research papers on the topic. He's the former secretary and chairman of the British Fertility Society. He was the chair from 2012 and 2015, and the secretary before that. He's also the current editor-in-chief of the British Fertility Society's journal. It's called Human Fertility, and I can only strongly remind you, always be kind to your editor, okay? This is a golden rule. It's worked well for me in the past. Harry Fisch is, and I know Harry for probably 25 years or so. Harry Fisch is currently clinical professor of urology and reproductive medicine at Weill Cornell College of Medicine, Cornell University. He is board certified urologist in the United States and a fellow of the American College of Surgeons. Dr. Fisch is the founder of Veru, that's spelled V-E-R-U, Veru, NASDAQ traded company, and has served as the director of the company since October 2016. As always, the bios and the potential conflicts of interest, including my own and the other moderators and of course speakers are all posted on our website. Today's speakers are Drs. Shanna, Swan, Rod Mitchell and Hagai Levine. Their bios are all online. Over to you, Allan.
Thank you, Jack. Thanks for that introduction. And nobody's ever called me a wizard before, so thank you for that. I think it's only fair that I should return the compliment. I'm sure the regular audience to these sessions knows Jacques, but if you don't, then can I just explain that Jacques is a hugely respected reproductive biologist, laboratory product developer and high complexity laboratory director. He's on the boards or advisory boards of many companies or bodies: ART Institute of Washington, IVFQC, and Athena Science, IVF 2.0, I assume that's how that's pronounced, Kindbody, TMRW, Phosphorus, and Daddy. I don't know how he has the time for all this. So it's great to be moderating with you and Harry here today. I've known you, Jacques, and we've encountered each other at conferences many times over the years, but I think this is the first time we've done a session together. So that's a great thing to be doing. So thank you for the invitation. And it's the first time I've met you, Harry, virtually. I hope we managed to meet face to face one day. It's really nice to be surrounded by two great giants in the field. You can be the giants, I'll be the wizard. So let's kick off tonight's session. And remember, everyone, this works because of your participation. So throughout tonight, if you have a question, please post it in the Q&A section in the menus downstairs, the Q&A button, not the chat, the Q&A button. And we have got a team of people behind the scenes who'll be watching that and helping us craft the questions for a great discussion after the talks. But let's get started. And our first speaker tonight, it's a great pleasure for me to introduce Rod Mitchell, who's Professor of Developmental Endocrinology at the MRC Centre for Reproductive Health at the University of Edinburgh. That's in Scotland. It's about 5 hours drive north of where I am at the moment. He's a consultant paediatric endocrinologist at the Royal Hospital for Children and Young People in Edinburgh, as well as a researcher at the University of Edinburgh. Now, Rod's very interesting in that he set up a clinical facility to store testicular tissue for young boys, and that was the first of its kind here in the UK, and that happened a few years ago under his leadership. So that I'm really respectful of Rod for having done that. However, it's Rod's research interests in the development of the fetal and pubertal testis that's of interest to us today. And his group's interested in the effect of endocrine disrupting chemicals on human testis development. Now, unfortunately, Rod can't be with us live this evening. And so we took the opportunity a few days ago to record his presentation. So Rod, over to you.
So thank you very much for the invitation to present to you today. And I'm going to talk about plastics, pills and painkillers, effects of in-utero exposures on male reproductive health. And I have nothing to declare. So many of you will be familiar with some of the more common male reproductive disorders that can present at different stages throughout postnatal life. And these disorders can occur in association with each other, and sometimes the collection of these disorders is referred to as a testicular dysgenesis syndrome. And it's important to recognize that one of the potential causes of these disorders is through effects that occur in fetal life, and in particularly in relation to a reduction in testosterone production in the human fetal testis. And the other thing that people may be aware of is that these disorders are generally increasing over recent decades, and this really brings into focus the concept that environmental factors may play a part in the development of these male reproductive disorders. And in terms of what these environmental influences might be that will program future male reproductive health, there are many, many different factors that have been suggested. You can see here just a list of some of those. But you'll also notice that the way in which these are thought to act on the human fetal testis is via either anti-androgenic or estrogenic effects. And of course, there's also the potential for direct cytotoxicity in the testis. And the idea is that these factors will affect these mechanisms to then result in these male reproductive disorders that we collectively refer to as this testicular dysgenesis syndrome in postnatal life. So what kind of factors are we thinking about? And I'm going to use just two particular proposed environmental factors to highlight some of the difficulties we have when we try and determine how they might be impacting male reproductive health. So I'm sure if you pick up any newspaper or look in any news article, you will often come across this concept of chemicals that are involved in making plastics and how they might be affecting our health in many, many different ways. And these include both the bisphenols, so bisphenol A or BPA we often hear talked about, or phthalates, which are another group of plasticizing chemicals. And these have been quite widely investigated in terms of their potential to cause male reproductive disorders. And I'm going to use phthalates as our initial example. So if you look at some of the epidemiological evidence to suggest that phthalates might impact on reproductive health, this is data from Shanna Swan using a cohort called the N-Haynes cohort. And what this study did was it was to measure the phthalate levels in the urine of women during the second and third trimester, and then correlate these to the anogenital index in the offspring, in the babies. So they measure between the anus and the genitals, and this gives a readout of the testosterone production that's occurred during fetal life. And what you find in this study is that there is an association between this particular phthalate, DBP, or its metabolite, MBP, and the anogenital index in the offspring. So this is suggestive that exposure to this may predispose to reduced testosterone in utero. But when you start to look at the animal studies, you start to see that the picture is a little bit more complicated than this. So here you can see an example of an exposure study, again using the same chemical, phthalates, DBP, and exposing rats during mid to late gestation. And what you find in these is that there is a reduction in testosterone and development of reproductive disorders. So very much the TDS-like phenotype in these rats. But if you do a very similar experiment, this time using mice and exposing them to, in this case, much higher concentrations of this phthalate, you don't see the same effects in the offspring. So this is really indicating very nicely the idea that there are clearly species-specific differences in terms of the impacts of these exposures. And just to highlight this, that it's not just one particular phthalate where we see this particular issue with differences from different studies and experimental approaches. This is a study this time looking at the phthalate levels in the mothers in the first trimester instead of second trimester, and again measuring the testosterone production by looking at the anogenital distance in the infants. And this time, instead of there being an association with the phthalate MBP that we mentioned in the previous one, this time we see an association with a different phthalate, MEHP. So what happens when you look at this phthalate in the experimental models? And again, we find the same, if you like, problem in that there is clearly differences between the species in relation to the response to this phthalate. So on the left-hand side, you can see that the rat fetal testis exposed in vitro to MEHP, there's a significant reduction in testosterone. So this would fit with what the epidemiological data would tell you. If you actually do the same or very similar study using this time human fetal testis tissues, you'll find that there's no reduction in testosterone. So this would go against the epidemiological data and indeed the animal data. So one of the challenges we have is finding the right type of experimental model to really test properly how these chemicals might impact in the human fetal testis. And so to try and address this, one of the ways that we've looked at this is to develop a system, an experimental model that allows us to give a more physiological type exposure compared to the in vitro models. And this is the xenograph system. So you can see that how this works is you obtain your human fetal testis tissues, but instead of culturing them in a culture dish, you graft them into a host mouse just under the skin of a host mouse. The mouse is then given hormones that mimic pregnancy, and you can then expose that host to the chemical that you are investigating and look for whether or not it impacts on the testosterone production from these grafted tissues. And to measure the testosterone in these grafts, we could measure either the seminal vesicle weights or the serum testosterone from the host mice. Both of these give an indication of how much testosterone these xenografts can make. And when you do the xenograft approach, what you find is that with exposure for either short term to this phthalate or a longer term to the phthalate, there's no effect on either the serum testosterone of the host mouse or the seminal vesicle weight of the host mouse. So really indicating that exposure to this phthalate does not reduce testosterone as would be predicted by some of the animal and epidemiological studies. And in fact, if you look at all of the data on human fetal testis exposure to phthalates and how these impact on testosterone production, you'll find that despite the different types of phthalates, different experimental models and regimens, none of these result in a significant reduction in testosterone. This is also supported by the in vivo data that has been generated in primates, so as close as we can get to an in vivo human study. And this study showed with using the marmoset monkey that if you expose these male monkeys in utero to, again, our phthalate MBP, you find that whilst you would expect to see these disorders, reproductive disorders occurring in the offspring of the exposed mothers, we find no evidence of any of these disorders in the in vivo monkey situation. So this is really telling us at the moment that whilst there's good evidence from the animal studies that phthalates can potentially impact on this aspect of reproductive development, the data from the human and primate studies are not so far supporting this. So if we come back to our potential environmental factors that might be affecting male reproductive health and move this time away from the plasticizing chemicals or some of the more ubiquitous environmental contaminants, we can think about the types of things that might be affecting reproductive health in terms of perhaps things that we are exposed to at much higher concentrations and perhaps more frequently. And so for the second example that I want to highlight, I really want to look at pharmaceuticals and in particular analgesics or painkillers. So why focus on analgesics and male reproductive health? Well, there are a number of reasons why these might potentially be important. The first is that we know that pharmaceuticals or the use of pharmaceuticals results in high exposures in those who take them. We also know that between 65 and 85% of pregnant women will use paracetamol at some point during their pregnancy, and they are the most commonly used medication worldwide. There's evidence that exposure to analgesics might have reproductive effects, and this is evidence from rodent studies. So this would suggest that these analgesics, and particularly paracetamol, might be important in male reproductive disorders. If you look at the epidemiology for analgesic use in pregnancy, and in this case, cryptorchidism, so one of our common male reproductive disorders, what you'll find is that there is evidence to suggest that there's an association between exposure to analgesics and specifically to paracetamol, often in the second trimester, with the development of cryptorchidism. So there is epidemiological evidence out there to support this. What about the experimental data looking at in vitro exposures? So this is in vitro exposure of in both rat and in human fetal testis, looking at the impact on testosterone production again. And what you can see is that from the rat fetal testis, when you expose during fetal life, then you have a significant reduction in testosterone production as a result of exposure to paracetamol. If you compare that to the in vitro studies using human fetal testis, and here I just want you to focus on the bars highlighted with the blue arrows, these are paracetamol exposed fetal testes, and you can see there's no significant difference between those and the white bar controls testis samples. So again, similar to what we showed for the phthalates, there are clearly species-specific differences dependent on the model that's used. But of course, as I've said already, the in vitro system is not necessarily reproducing the situation in vivo. And so to get as close to that as we possibly can, again, we turn to this xenograft model. So we use the xenograft model to look this time at the impacts of paracetamol exposure on the human fetal testis. So to do this, we expose human fetal testis xenografts by treating the mother with paracetamol. And important to note, we use the same doses that would be used clinically for patients. We also stimulate these xenografts with the maternal pregnancy hormone to try and mimic that environment. When we then measure the paracetamol in the host mice, what we find is that the level of paracetamol in the serum of the host mice still remains well below that we would expect after a therapeutic dose. So any effects are clearly in the therapeutic range. So when you look at the impact of paracetamol exposure on testosterone production in these human fetal testis xenografts, you find that when you expose for the 7-day period, there's a significant reduction in the testosterone production in these testis tissues. So clearly this is showing that paracetamol can impact on testosterone production. However, when you do the same study, but this time instead of exposing for a full 7 days, you expose just for a single day, you don't see the same effect on testosterone. So this is really suggesting that it's potentially prolonged exposure to paracetamol that might be able to impact on testosterone development production. So the data that I've shown you so far for both the phthalates and for paracetamol is in terms of the testosterone production, which we know can predispose to subsequent male reproductive disorders. But what about the idea that these agents might actually directly impact on the germ cells themselves that could then subsequently affect fertility? And so to do this, we looked at our xenografts, but this time looked in the tissues themselves after exposure. And we measured or quantified the number of germ cells, total number of germ cells, which involves 2 different populations in the fetal testis. And we added the number of germ cells from these 2 populations together to get our total germ cell count. And when you look at the total germ cell number by quantifying, staining the cells and quantifying them, as you can see here on the left-hand side, when you quantify those germ cells, what you see is that 7-day exposure to paracetamol will give you a significant reduction in the germ cell number. And this is also what we found when we exposed these human testis xenografts to ibuprofen. We found a similar reduction in the germ cell number. So around about 50% of the germ cells are lost as a result of exposure to either of these analgesics. So we clearly see an effect on testosterone, and we clearly see an effect on germ cells with exposure to these analgesics. So of course, the next question that always comes after this data is presented is, what does this actually mean for humans? And of course, the media always like to pick this up in sensationalist terms and produce some quite eye-catching headlines with this. But what does it actually mean for humans? And this is where we need to be considering the implications of these results, because it's not clear at this stage exactly what degree of testosterone suppression or germ cell loss will result in reproductive disorders. And it's also important to recognize that controlling pain and fever during pregnancy is also important for health of the fetus. So despite the fact that we have this evidence with analgesic exposure, we would still be advising that if it's absolutely necessary, then the use of paracetamol should be at the lowest effective dose for the shortest possible time. We still need more studies, and we still need more information of exactly what the implications of exposures might be for male reproductive health. So what I'd like to hope that you'll take away from the talk that I've given to you is that animal models are very helpful in testing hypotheses. They also help us to identify new mechanisms that might be behind environmental impacts, and that includes on male reproductive function. But we also always need to be very wary of species differences when we're trying to do studies that investigate the effects of exposure on testis development and function. And where possible, we always need to be trying to validate the findings of these particularly animal studies with human testis tissue experimental approaches, and also marry these up with the human epidemiological studies in order to properly translate what we're finding into a human relevant or clinical situation. And whilst I've focused for the purposes of this talk on just two particular environmental chemicals, of course, we are exposed to thousands and thousands of different chemicals all the time. And so if you want to know a bit more about the evidence behind other chemicals that have been proposed to play a role, then these two papers, one looking at the epidemiology and the other looking at the experimental evidence for effects of environmental exposures on human fetal testis development and male reproductive function, I would draw your attention to these two publications. So with that, I would like to thank those that are involved in some of the studies that I've shown and for their involvement in our work going forward. I'd like to thank you for listening. I look forward to getting some questions, and also there is contact information in case anyone wants to get in touch. And thank you very much.
So that was a great talk by Rod Mitchell there, kicking us off tonight and showing instantly, I think, the complexity of the testis and how it responds to various agents and how that differs between experimental models and between different species. Now, as I said, Rod can't be with us live this evening. That was something we recorded a few days ago. So when we did that recording, I took the opportunity to ask him a few questions about his talk. And I began by asking him to clear something up, a conundrum in my mind that I've had for a while about endocrine disruptors. And I'd always thought that it was exposure to environmental estrogens or estrogen mimics that was the important thing in affecting fetal development. But Rod mentioned at the beginning of his talk about factors which might be anti-androgenic. So I asked him what was more important. Was it factors that increase estrogen in the fetal testis, or was it those that reduce testosterone? And we have a video somewhere of his answer, if we could have that played into the conference tonight.
This is a difficult question. So I think historically the feeling was that either a reduction in testosterone as being a pretty relatively robust mechanism for how this might occur was well established. And previously it was very much considered that an increase in estrogenic exposures would also do a similar job. And one thing that is now a bit more recognized is that the human fetus is actually exposed to pretty high levels of estrogen already. And quite often the amount of estrogen in these environmental chemicals is actually minuscule in comparison to the amount of estrogen that's actually circulating already. So I think that the kind of estrogen hypothesis which was out there has some challenges now in relation to exactly that the high levels of circulating. There is still some idea that maybe there can be a balance between testosterone to estrogen ratio as being important, but again, it may well be that it's swamped by estrogen in the first place. So bisphenol A as being one of the sort of weakly estrogenic chemicals that's often reported, I think that we still have to deal with that with some degree of caution, perhaps.
Great answer.
Thank you.
You've highlighted through what is a very elegant model, your xenograph model, that we sometimes have to be cautious about how we interpret some of the animal experiments out there. Do you think that is a serious problem in our history? Do we, if we're making policy from animal data, do we have to relook at all that data? Is that where you're taking us, where your research is kind of heading?
I think to some degree that's true. And I think that there's two things really. The first thing is there are clearly species differences in response to chemicals. As a general rule, there can be species differences. And so we have to recognize that can happen. And when you do almost identical studies in two different species and get different results, that's what that's telling you. There's also the other issue that quite often the animal studies, it's not necessarily even just that it's the species, it's the way in which the study is done. It does not reflect the way in which we are exposed, for example. So a lot of the data that I showed there in relation to the phthalates are enormous doses of phthalates compared to what we would ever be exposed to in reality. So it's not just necessarily the species is not correct. It's also that the way in which the experiment's done may not be correct. But that's not to say that there potentially are animal studies that can be designed to accurately mimic what happens in human situation, but we have to always assess all the studies that we see in terms of, is this accurately reflecting what's happening in the human?
You quite rightly, I think, highlighted the interest that the media has about this and the way that some of this data is interpreted and presented to members of the public. So as a final question, if you were in the position of advising a newly pregnant woman about how she might change her lifestyle or behavior during her pregnancy, what would be the key message that you would say to her?
So I think when it comes to advice for pregnant women, then I think we should be encouraging a healthy lifestyle along the lines of what we would all consider to be a healthy lifestyle. In terms of environmental exposures, then it's very difficult to completely reduce or avoid exposures to many of these environmental chemicals which are surrounding us all the time. And so therefore, I think for that, we need to be really taking a very pragmatic approach, which is to reduce exposures where practical, but without being completely restrictive on the way that we live our lives. In terms of pharmaceuticals, then for prescription pharmaceuticals and medications, it's important to discuss these with your healthcare professional either before you become pregnant or once you know that you are pregnant. But for non-prescribable or over-the-counter medications, then for these it's important firstly just to recognize that these are medications and all medications can potentially have side effects, and that where possible the use of over-the-counter medications is discussed with a healthcare professional before taking them. But if they are felt to be necessary to take, to ensure that these are used for the shortest possible time and in the lowest effective dose.
Well, that was an outstanding presentation by Rod, and the answers were really right on target. I just want to make a statement before I introduce Hagai, is that, sometimes we think about environmental issues. Is it the environment that's causing something like environmental estrogens, or is it the personal environment? what the woman or man tend to ingest, analgesics, what have you, and there's a certain rise in those medications. I just want to add that as a urologist treating infertile men, I would always tell men, don't take anything, not even antibiotics, because we even know antibiotics such as ampicillin, penicillin can adversely affect sperm production. So I thought, that was just a fantastic presentation. Now I want to, actually introduce Professor Hagai Levine. And I think, Hagai, this is probably your first presentation of the new year. So I'd like to say Happy New Year. Professor Hagai Levine is a public health physician and environmental epidemiologist, professor at the Brown School of Public Health and Community Medicine at Hadassah Medical Center and Hebrew University in Jerusalem, Israel. Founder and first director of the Environmental Health Track and one of the founders of the Advanced School of Environmental Studies and the Research Center in Agriculture and Environmental Health. Professor Levine has published more than 100 peer-reviewed scientific articles. His extensive work examines the environmental, biologic, and chemical threats to public health and the response needed, with focus on male reproduction and the impact of maternal exposures on the developing fetus. In 2017, Dr. Levine, together with Dr. Swan and other colleagues, published Temporal Trends in Sperm Count, a systemic review and meta-regression analysis, which received extensive worldwide media coverage. Welcome, Hagai.
Thank you, Harry, and greetings from Israel. And indeed, we just started the new Jewish year, and actually the acronym for this year, Taf Shin Pei Bet, is Let It Be a Fertile and Healthy Year. So I wish that for all of us. And it's very good as someone who is dealing a lot with COVID-19 to do something else at these times. And maybe even more important, as we are facing a silent pandemic, let's speak about it. So we actually try to answer this question: have human sperm count declined? By our research, which was published in Human Reproduction Update in 2017, and I'm sure that many of you have seen it. As in the paper, and it's still now, I can declare for myself and actually for my co-authors that there is no conflict of interest. Why sperm counts? So not only for kings like David here, we know that despite the limitation, sperm count are a marker and are needed. Of course, with zero sperm count, you cannot reach male fecundity. But more than that, evidence from recent years have shown an association between sperm count and general health of man, including longevity. Also, it's a great model, as we saw and we'll see later on with Shanna's presentation, to study the impact of the environment on health. And we can also advance science by understanding better spermatology. It's really a great aspect of life itself. Luckily, for a meta-analysis, the methods that is used to count sperm using hemocytometer have not changed much over the last decades. So we can actually study trends over time with a validated measure, unlike some other measures of our body, which the measurement system changed significantly over time. So our goal was to conduct a systematic review and meta-regression analysis. A meta-regression is like a multivariable model of a meta-analysis that you can adjust for other factors of recent trends in sperm concentration and total sperm count, hereafter SC and TSC, and their modification by fertility and geographic groups. The important thing about the meta-analysis that we don't want to look only at the individual studies, such as looking at the trees in the forest. We want to see the whole forest to answer this global question. In order to do that, and I strongly recommend for any one of you who want to conduct a meta-analysis, you need a multidisciplinary team, and you can see here my co-members of the team, Shanna, Swan, and others. And we are actually, I can reveal here for the first time that we are actually doing now MRA 21, as we call it, an updated meta-regression and systematic view and meta-regression analysis of this subject. Overall, after reviewing over 7,500 papers, we reached with 185 publications that met our eligibility criteria, and I skip over much of the methods here because it's in the paper and for the scarcity of time, from 50 countries. And you can see, generally speaking, we can separate that by 4 different groups. The main group, and actually that's also was from the first place, our main group of interest was the unselected men. We tried as much as possible men from the general population. The other group is fertile men, meaning from recent fathers or where their spouse or partner is in pregnancy. So that's fertile men or unselected men, and either Western or other, which was needed for the statistical analysis. You can see that the main group is the unselected Western. When you do a simple regression, and I don't like to show this graph because the simple regression is not the right statistical model to describe the data. But despite that it's scattered all around, there is a clear overall decline in sperm concentration over time with a slope that is pretty similar to what was previously found by Carlson et al. And Swan et al. But the more important model is the meta-regression model, which you can account for other variables and you can adjust properly for statistically. And here, for the main group of unselected Western men, you see over 50% decline from a mean of 99 in 1973 to a mean of 47 million per ml in 2011. Now, if you look at the numbers itself, and I know that there was, discussion, a lot of discussion after the paper was released, you should actually look at the numbers and not only at the graph. And if you look at the number, you see a clear decline for the unselected Western and also a statistically significant decline for the fertile Western group. For studies from other countries, meaning from Africa, South America, and Asia, it was not possible to conclude what is the trend. You see here the confidence interval is too wide to know what is the trend. So even though in the graph you may think, okay, maybe there is a decline here and maybe there is an increase here, that's not true. What we said, we cannot conclude what is the trend for other groups. We can conclude that for men from Western countries, meaning North America, Europe, and the trend was very similar, Australia and New Zealand, there was a clear decline. That was also true for total sperm count with a very similar trend, and nearly 60% decline over the time period of the study. The year is for the year of sample collection, not the year of study publication, of course. So what is the meaning? Obviously, we are not saying that it's going to decline to 0 in the future, as we are not saying that it was in the 1000s in the past. As Niels Bohr said, prediction is very difficult, especially about the future. And the headlines in newspaper about spermatozoa at the verge of extinction, that was from journalists. But here we see a clear signal, and like the canary in the coal mine, we should not only treat the canary, we should find what are the causes and treat the causes of this clear and present problem for mankind. And actually, at the Stockholm Conference of Spermatology, we issued the statement, the Stockholm Male Reproductive Health Statement, and we acknowledge the importance of male reproductive health for the survival of the human and other species. And we need to increase efforts and resources allocated to studying the causes of disruption of male reproductive health and to implement policies to remove others. And was said earlier by Rod Mitchell, similarly as you would recommend to any pregnant woman to live a healthy lifestyle and to live in a safe environment, that is also true for males. Unfortunately, even during the pandemic, I'm not sure that that's the case and that our call was really well heard and the reaction followed. You can ask, is it environmental or genetic causes? So unlike the common wisdom, you know, what we say that how do you tell if it's environmental or genetic? You look at a newborn son. If it looks like his father, that's genetics. If he looks like his neighbor, that's environmental. Well, what we say that everything that is not genetic is environmental. So Harry just said, we do not say either it's specific, and maybe Shanna would elaborate on that, but either it's a specific environmental causes or environmental causes in the social sense, or for example, climate impact, etc. It could be many different environmental reasons, but clearly the decline in sperm concentration in humans could not be explained by genetic change. And indeed, the United Nations actually took our study and declared that sperm count decline could be seen as a sign for the existential nature of our own toxification. And together with a lot of other evidence, it's clear that we are having high exposure to many man-made toxic chemicals that have major effects on our own health and the health of future generations. As you can see here and pay attention, prevention is the best medicine. It's always should outweigh cure, but that's not how we treat. And unfortunately, I also see that in COVID-19 response. So we should not be like the ostrich that is claimed to put its head in the sand, but actually the ostrich is doing that in order to take care of the eggs that are in the sand. You can read here, and the optimist would read, opportunity is now here, because mankind is putting more attention to health now. And the pessimist would say, opportunity is nowhere. So I am here to stay, and I will gladly discuss and have collaboration with any of you to see how we actually tackle this problem. And it starts by acknowledging that there is such a problem of decline in human sperm count. Thank you very much.
Hagai, that was an exceptional presentation. And your the way you described genetic versus environmental is the best explanation I've ever heard. So with that said, I do have a comment, and this work is so important because there's clearly a decline in sperm count in certain individuals, certain groups, while there may not be in others. But you know, in your study, you said there's about a 50 to 60% decline among unselected by fertility Western, right? I'm just repeating. And what was interesting to me, and I think fascinating, what does that mean, unselected by fertility? Example, young men unlikely to be aware of their fertility, such as young men screened for military service or college students. To me, that is such an important statement because, you know, I have 3 children. You don't know that, but I have 3 children, and they all look like me. So the important thing is, when I sent my kids to college, I'm just happy they didn't become alcoholics. I mean, the amount of drinking and the amount of partying is just unbelievable. And as you know, excessive alcoholism, of course, marijuana use, drug abuse. You know, young men now are taking anabolic steroids to increase the way they look. And that has a direct implication, a direct decrease in sperm counts. And of course, you know, the opioid epidemic. People take any opioids, it just goes straight down. So I so much agree with, and I'm so glad that you brought up this particular age group, because I think those are the ones that are most at risk, these young people. And it may not be, you know, something that their mother, you know, like it's not their mother caused it. That's clearly, what therapists are for, blaming the mother for everything. It is, again, that personal environment that these men are doing. The other thing is why I think it dovetails into my theory, because there's no way of proving it. But as you know, or may know, that there's been a decrease in fertility rates and birth rates among teenagers. Now, you may say there's more contraceptive use, there's ease of contraception, there's less abortions, more abortion. That's all nice, but it could easily be, because when you talk about teenage pregnancy, that's amazing that it's going down, could easily be a drop in sperm counts. And I think that could be the canary in that mine shaft that you're talking about. So I commend you for your work, and I appreciate it.
So just if I may, just to say about that, I also have 3 children, and I'm also worried about them. The elderly is getting now 15 years of age. The point is that when we look in a meta-analysis, and I'm speaking as an epidemiologist, take it or leave it. But if you take similar studies, and it's good, I was interested because in Israel I prepared a report for the Israeli Minister of Health in 2009, and we also saw adverse trends in Israel, also a massive increase in use of fertility treatment. And that's really life-saving, enabling people to bring children to life. But we should also acknowledge what is causing the problem. So when you look at generations, you actually see, and you said it could be due to other reasons, lifestyle reasons as well. But you could see that from generation to generation, we do see a decline, not only in sperm count, but also from other evidence, not from our study, but also in male fertility. So, I hope that by this webinar, people may take it and continue this kind of studies that are really needed in order to understand what is causing the problem.
Thank you very much. Hagai, thank you again. Over to you, Jacques.
All right, thanks, Harry. And thank you, Hagai, and also before you, Rod, for these great presentations. I really enjoyed it, and there's more to come. It's my pleasure to introduce to you Professor Shanna Swan from the Icahn School of Medicine at Mount Sinai in New York. Dr. Swan is an environmental and reproductive epidemiologist and professor at Environmental Medicine and Public Health. Her work is extensive, and it examines the impact of environmental exposures, including man-made chemicals, such as the phthalates that were mentioned before, and of course BPA, on reproductive health and the neurodevelopment of children. Professor Swan and others launched massive multi-center pregnancy cohort studies more than 20 years ago, ongoing studies to better understand how prenatal and early childhood exposure to stressors impact the reproductive health and neurodevelopment of children. These and the study with Dr. Hagai Levine that was just reported on, that sort of inspired her to write this book that was basically had an enormous impact earlier this year. It was published at the end of February in 2021. And the book called Countdown, and the subtitle is How Our Modern World is Threatening Sperm Counts, Altering Male and Female Reproductive Health, and Imperiling the Future of the Human Race. I've listened to it on audiobooks. The audiobook came out very quickly. It was well read, and really it took my breath away. So outstanding job, I think, and it has had an impact also on the media. This is not just another dystopic vision, this book. It's a book of hopeful science presenting countermeasures. Okay, so we're finding this. Some may not be relevant, some of them may not be true, yet what can we do about it? So looking very much forward to your lecture, Shanna, and we're grateful that you are joining us for this webinar.
Yes.
Sorry, yeah. Now we can hear you.
Okay, good. Okay. So what I'm going to talk about here today, and I'm so glad to be following Rod and Hagai, because our talks really work together. And I want to thank, before I do that, I want to thank Jacques, and I want to thank Giles and other people in I call it IIVF, probably not right, and also the sponsor, and to tell you I have no conflict of interest. So here's a roadmap for what I'm going to talk about. A brief summary of what we talk about in Countdown, most relevant, I think, things that are most relevant to the issues we have today. I'm going to talk about the problem, its causes, its consequences, and its solutions. So I'm going to start with the problem. And you've heard a lot about the problem from the other two speakers, and that's fantastic. And in particular, you've heard about our 2017 analysis from Hagai. But I want to point out that even though that analysis, which you can see summarized on the right, had a strongest finding in Western countries, I want to point out that about the same time, in fact, the same year, a paper came out in African countries showing an even steeper decline. There are other papers from China and from other countries. So because we did not find a significant decline in what we called other countries, those that were not North America, Europe, Australia, New Zealand, it does not mean that has not been a decline. It's just that these other countries have not published to the same extent as the so-called Western countries. So what I'd like to focus on now is to tell you that it's not just sperm concentration in Western countries. And Hagai talked briefly about birth rates going down. This should actually be the fertility rate. This is a total fertility rate that has been going down, and at about the same rate. So back in 1960, it was 5 children per woman, and most recently about 2.4. And at the same time, other rates have changed at a similar pace. So miscarriage has gone up, endocrine, ED has gone up, testicular cancer has gone up, and so on and so forth. So when you put these all together, you see a host of reproductive problems in males, in females, and those that occur as a result of both male and female influences. So I'm going to talk now about what could be causing this. And of course, both Rod and Hagai have talked about this quite a bit. So what I've done here is to break out the possible causes schematically in a way that I think would agree with what the other speakers had said. If you take all possible causes, you could separate them into genetic and environment. And as has been said so well by Hagai, genetics is not going to be the likely explanation of something that has changed so dramatically in 2 generations. It just doesn't work that fast. So then you're left with environment. So you can break down environment into 2 classes as well. And I do that into chemical exposure and lifestyle factors. And then you can break them down further, as I'll be doing. So if we look at lifestyle factors, we're talking about the factors that other speakers have alluded to, things like smoking, other behaviors, alcohol, drugs, also obesity, activity. So a range of threats to our overall health also impact our reproductive health. And it's not surprising that the advice that you'll get or give as physicians for heart disease or heart health, metabolic health are also recommendations for your reproductive health. But then if you turn to chemical exposures, there are 2 classes that you can break these into, which I call other, because what I'm going to talk about is the EDCs. The EDCs are the chemicals that we call endocrine disrupting chemicals, sometimes called hormone mimics. And these are chemicals that have the ability to alter our endogenous hormone systems. And if you want to look at some classes of those, Rod has talked very beautifully about phthalates. There's also the bisphenols, and by the way, not just bisphenol A, there's bisphenol S, there's bisphenol F. And the PFAS chemicals, those are the barrier chemicals on Teflon and coating your jacket to keep off the water repellent. There's pesticides, there's flame retardants. But I'm going to focus, actually, because that's where most of my work has been as rods, on the phthalates. So before I do that, I just want to kind of summarize these for you. It's not just phthalates, right? Teflon, phthalates in rubber duckies, flame retardants in cushions, pesticides, bisphenol A in tin cans, phthalates, which help us retain scent and color. But most important to the story, for me, as it was for Rod, is the presence of testosterone. And this very simple schematic is just to point out that the undifferentiated sex organs very early in gestation require testosterone for the genetic male typical development. So what can interfere with testosterone? Well, one class of chemicals are the phthalates, which, as I said, are found in cosmetics because they retain scent and color. They're found in our homes in soft plastic products, and they're found in industry whenever there's soft plastic tubing. So we're exposed to these massively all the time on a regular basis. Fortunately, they leave our bodies in 4 to 6 hours. So if we could stop them coming in, we'd be able to get rid of them. So this is a very early study from 2000. It's just to illustrate that there is a critical surge in testosterone in early pregnancy. And Rod has actually worked on this problem too. And it's just a few days long, actually. You see this peak. And when the mom is exposed, in this case to DEHP, diethyl hexylphthalate, that peak is wiped out. And in a female, it doesn't matter much because she's not depending on that testosterone and she doesn't have very much of it. So there's been some talk about the dose that people are exposed to and animals are exposed to. And I just want to mention that while the initial studies were done at very high doses, they were done one at a time. We're not exposed to these chemicals one at a time. So this very nice paper that came out just this year looked at a mixture of phthalates and pesticides that are very low level and showed that there was a reduction in fetal testes production and a reduction in the anogenital distance, which I'll talk about more. So it's not just high doses we're talking about here. So in 2005, Paul Foster, Earl Gray, and others published a very important finding, which is that when the mother was exposed to phthalates that were anti-androgenic, in particular DEHP, that what happened was that the male offspring exhibited what they called the phthalate syndrome. Interestingly, there's not too many syndromes which are associated with toxic exposures in utero. One of them is fetal alcohol, but this was the first environmental chemical that I know of, and perhaps the only one that's been given the name of a syndrome. And that has the characteristic of smaller genitals, smaller penis, and a malformed penis, undescended testicles, and a shortening of the anogenital distance, which you all know is the distance from the anus to the genitals. So I asked, what about humans? Now, Rod has talked a lot about the translation from animal to humans and how we have to be careful about that, and I agree. But I have to say, this was my impetus for doing these studies, and I think it was great that I took that animal data and that animal model and translated it into humans. So what I did was ask if we could get a urine sample from the mothers, measure levels of phthalates, and then examine the babies, we'd be able to see whether those measured levels of phthalates are related to the genitals of the offspring. And fortunately, I had a study in which I had stored urine from the mothers, and I was able to bring some of the babies back and actually measure their genitals using a translation of the animal model, which was interesting because it hadn't been done before, but turned out that you can measure these things pretty repeatably and accurately in human infants. And then, because science requires replication, we did it all again 10 years later in a larger cohort more carefully. And so we confirmed that the phthalate syndrome is seen in humans. We confirmed it in 2 papers, And the results have been replicated in many other studies. So in summary, the prenatal phthalate exposure causes the phthalate syndrome in human males. And we've also shown phthalates are anti-androgenic, they're endocrine disruptors, and AGD is a marker of this fetal androgen exposure. So then you can say, well, what does this have to do with the sperm count story that Hagai talked about? And this, I have to say, leads us to a place where we have a gap. So we have not been able to follow our infants in which we measured AGD to the time when we could get their sperm count. It's too long. That hasn't happened yet. However, in animal studies, AGD is a permanent marker. That's been shown in a number of studies. And if that is true in humans, and I recognize that that is an if, then it makes sense to look at adults and ask, is AGD related to sperm count? And we did that in Rochester, New York. And we showed that in these college students, the longer the AGD, the higher the sperm count. So we found a link between this measure of androgen exposure to sperm count concentration. And then Michael Eisenberg did something similar in Stanford and showed not only is it related to sperm count, but also that there's a difference between men who were childless and men who were fathers. So there seems to be a relation to fertility as well. By the way, AGD is also linked now in a recent study to testicular cancer, and it's also been linked to hypospadias cryptorchidism. So it does seem to be a marker of the testicular dysgenesis syndrome that Rod talked about. And in fact, Neil Skekebek, who originated that term, has incorporated AGD as part of the TDS, the testicular dysgenesis syndrome. So now I'd just like to talk about the fact that timing is really important to this story. In fact, timing, you might say, is everything. So the group that Rod works with, part of that group, published a very important paper in which they teased out very elegantly the critical window, which they called the male programming window, during which this disruption of AGD can occur. And it's very short, it's 3 days. And we asked again, because I translate these things into humans, what about humans? Now, in our first study, we only had 1 urine sample and we couldn't answer that question. But in our second study, we did get a urine in each trimester. And what we showed was that the association between DEHP and AGD was only significant when the exposure was in the first trimester. So while we haven't been able to tease it out as elegantly as that short period that was done for rats, we do know that it's going to be in the first trimester. There's another way that timing is important, and I just wanted to stress this. This is a series of studies, mostly out of Denmark. It's not about phthalates, it's about smoking. I used to illustrate that when the father smokes in the periconceptional period, that 60 days, 70 days that sperm is being produced, he will affect his son's sperm count by 40% reduction. When the mother is smoking during the first trimester, that will be associated with a 40% reduction in sperm count. If the man himself smokes, that smoking will be associated with a 20% reduction. But here's the kicker. If he stops smoking, his sperm count will recover, but there's nothing to do about the exposures periconceptually or during pregnancy. Those changes are permanent. And that's why prenatal exposure is absolutely critical. So I'd like to talk briefly about some consequences. The first thing, Hagai alluded to this, that men with low sperm count have all kinds of health problems, particularly heart disease, diabetes, cancers, and in fact, they die sooner. And this is a paper from Denmark using very large databases to show that whether or not the man had a child, the closer his sperm count gets to 0, the higher his probability of early death. I also wanted to just mention the increase of IVF cycles. So one consequence is the increase in IVF. And this is the graph from Israel. And Israel is one of the few places, Israel has the highest rate of IVF in the world. And for two reasons. One is that it's free. Women get two conceptions, the chance to have 2 children free. And also there's a culture where it's a duty, if you will, to produce children. So there's a strong drive for reproduction, and this is covered, So this is kind of what you see, what would happen probably in other countries if every country paid for this. You see this huge increase in IVF. And I want to point out that the effects of an exposure to the mother don't stop with the mother. They affect the fetus, and then they affect the germ cells, so that the 3rd generation at least is also affected. Some studies actually suggest that subsequent generations are also affected by that grandparental or great-grandparental exposure. And finally, I want to say that the same chemicals that are affecting us are affecting them. We have decreased fertility in a huge number of species, a rapid increase in the number of endangered species, and many, many studies linking environmental chemicals that challenge our reproductive health, challenging the reproductive health of these species. So finally, I'd like to briefly talk about some solutions. One is to note that we have not tested the chemicals to which we're exposed. In fact, it's really a big experiment in which we are the guinea pigs. Against our will, we've never given permission, but in fact, the chemicals are put out into products, they're not tested, and if people get sick, then you do the studies, and maybe 10 years later, you can switch out bisphenol A for bisphenol F, which is no help at all. So the testing has to increase, and it has to be done properly. And Rod talked about how we're not testing at human relevant scenarios. And I want to emphasize that, and also say it's not just the dose, it's also mixtures, because we're exposed to mixtures. And it's also that we have to test at low doses, because that's what we're exposed to. So low doses and mixtures are really critical, and also the route of exposure. So dermal exposure to phthalates, you're not going to get that through a feeding experiment. So here's something that we need to do. We have to remove from commerce chemicals that are hormonally active, that cause harm at low doses, that persist in the environment, and that are untested. That's our #1 priority. Then we have to replace those with chemicals that do not have endocrine disrupting effects, that is, are not hormonally active, that do not have adverse effects at low doses, that do not persist in the environment, and are actually shown to be safe prior to marketing. And then we have to regulate those chemicals by assessing low dose effects, mixture effects, their environmental persistence, and the risks in those chemicals, which are still untested. So I'm going to stop here and answer questions. And I got a great plug for the book Countdown. I'm showing it here. I just mentioned that you can order it, and you can contact me and follow me. And I hope to hear from you all. Thank you.
Well, thank you, Shanna, Swan. Thank you so much for this lecture. We've had 3 great lectures. We have quite a few questions for everybody. We start with you, Shanna. And we have both Allan and I made comments about one question that came from David Mortimer. In case the moderator doesn't know who David Mortimer is, it says here between brackets Sharon's husband, which is great, because of course this is David Mortimer is Sharon's husband. This is true, but this question is, what about the impact of contraception access and use, especially oral contraceptives, on perceived fertility since the 1960s? So
I think that question has to do with contraceptive use in relation to fertility rather than sperm count, I'm assuming. So undoubtedly, availability of contraception has driven down the total fertility rate. There's no question about that. So it's access to contraception, it's women's education, it's women's role in the workforce have been very, very important. That's not to say that environmental chemicals are not playing a role. So, you know, it takes two to tango. The couple has to decide to get pregnant, has to want to do that. And by the way, we are also seeing a decrease in sexual drive and libido. I can give you some citations if you want, associated with these chemicals. So these chemicals could actually act in a more subtle way than I've shown you here, but can act to actually make the couples maybe not have sex as frequently, or maybe not want children. So there's a lot of other impacts than those I've outlined here, but contraception is definitely important.
Yeah, great, thank you. Harry, I think if you take over the Q&A session from this point, that'd be great. Thanks again, Shanna.
Thank you. If anyone has any questions, we have the Q&A section now, so I'd love to hear. And any of the moderators have any questions, you know, I'd love to bring those up. May I start with the first questions until we get some from the audience? Professor Hagai, you know, it's such a great presentation, but one of the things that I think that may be a misconception, if you will, if that's the right term to use, is, you know, the methods. You like that, Shanna? Huh?
Yeah, right.
Maybe that should be the title of your next book, Misconception, right?
That's great.
Right?
Yeah.
So one of the things, you know, I've been a urologist for a very long time, always a fertility doctor. And one of the problems that I had starting out was the counting chambers, the ability to count sperm were not really, they were variable, to say the least. And back then we used to use the macular chamber, and still the macular chamber is used. And I invented the cell view counting chambers, which are the disposable counting chambers. And when you compare the two chambers, there's a big difference in accuracy. So one of the questions, not really a question, more of a comment, is that I wish in the future that we have the ability to really compare apples to apples instead of apples to oranges. And I think that may be, Allan, something that we may want to do at a different symposium on exactly that, because one of the major problems, and I published on this in the last century, by the way, was that we really need to standardize. So I disagree a little bit about the comment about, you know, the standardization of sperm counts, because it is so variable still.
I think that you touch a very important point, that, you know, we should also look at the future, because people could say, okay, it's impossible to know the truth. Okay, maybe we can discuss the limitations of current evidence and then set a program that 20 years from now, we will know more. If we continue to say, okay, it's very difficult to know, we will never know the full answer. So we hope, Shanna and I and others, we hope that governments and funding agencies would tackle this issue. And, you know, with 1 million of the money that is put to COVID-19 testing, and I'm saying as a member of the national team in Israel, we are doing so much testing for COVID-19. If we take 1 million of the money that is used for something that is for very short time for decision making, and use it to better understand in the future what is going on with male fertility, with men's sperm, we would be more knowledge. Just to say, the macular chamber specifically, as I understand, was invented in Israel, and actually we excluded studies that use the macular chamber exactly because what you said, in order to avoid comparing apples and oranges, even though, you know, that's a legitimate methods, but if you do it with other methods, then there is a problem for the meta-analysis. So I totally agree. We tried, and if you look at the study protocol, we had a very detailed protocol and tried to compare apples to apples, which is one of the challenges in a meta-analysis.
Can I just add one thing, Hagai, to that? I think it's all great. I just want to say that we need to remember the difference between error that is random and error that is consistent. So unless you could show that the changes in counting had led to counting fewer sperm, that those changes could not explain the decline. And I tried to do that. You know, I've done many analyses and I looked at this, and as far as I can see, the variation in counting, which is certainly there, and I learned to count sperm and I know how hard it is random. I see no trend in the changes in method.
I'm not sure I agree with that, if I can come in. So I sit and oversee the UK National Quality Assurance Programme for andrology. And when we look over time at laboratory performance, we see the same kind of smooth regression line that has been reported. And I think it's, you know, QC material does not change. But what does change is people's approach to training and people's commitment to quality control. And so I've publicly said, you will be aware, I still have a doubt about our use of retrospective data in the way that has been published. But I share Hagai's concern about why haven't we done a prospective study? And if this is such an important question, why haven't governments committed resources to do a prospective study? If we'd started that 30 years ago, we'd know the answer by now. And I think that's a source of personal frustration to me, that we haven't had that level of commitment from our governments and funders.
And by the way, if you have a cohort study for any other reason, you could add into cohort studies, semen analysis. It's such a wonderful marker for all kinds of things. You know, it's just something that it's also for us epidemiologists that we don't do enough.
Yeah, we tried that in the UK and we didn't manage to get that on board with the pandemic. I've got a question here, if I may, that's been highlighted by Giles, and it's from Ghulam Bahadur down in London, who does make a comment about the statistical models that are sometimes used to look at the sperm count decline, and whether you know, the choice of model might explain some of the decline. Do you have a comment about that? I think he published a paper in 1996 by the looks of it. Are we sure we've got the right models?
Okay, you want to take that? Yeah.
Well, you know, I just have, it's in Hebrew, but I have a book here about Galileo and the denial of science. So it's not about, you know, having, we possessed a theory and someone else got another theory. It's about the peer review process that we try to get closer to the truth. And, you know, Shanna, when she started looking at this question, and when I started later looking at this question, we didn't came with an agenda, and we didn't came with this is the direction. We wanted to find the answer to the question: what is the trend? It could be increased, it could be decreased. Now, when you look at models, models are all models are wrong. Some of them are useful. That's what the statisticians are saying, and we see that also with COVID-19. And I personally went in the international and the Israeli media to warn against models, because we need real life data all the time. So again, I'm calling governments and scientists to use real-time data on semen parameters as well. And the situation may be different in Israel and in the UK and in Brazil and the United States, etc. But with that said, for the meta-analysis, we took all the criticism that was on previous analysis. We presented it in conferences, we presented here, and everyone, we published the full data for if someone wants, and we published a detailed protocol, and we tried to answer the question. We had dozens of sensitivity analysis. We took each time, each study. We did all kinds of things to see, and the model was robust. And the decline is significant. You know, when you see, again, I'm saying as epidemiologist, when you see a very sophisticated statistical model, be careful. When something is clear, you can see it with a simple statistical model. And I was amazed. I remember I came to Shanna and showed the preliminary results. And then we are worried because of the responsibility that we see such an amazing decline. It's unbelievable. Imagine that, you know, our BMI would increase by 50%, or that our IQ would decrease by 50%. It's amazing.
I think, Hagai, I totally agree. I think we're all on board. This panel is on board. I think Ghulam is pointing out a study that's very similar to Harry's study, published in the same year, 1996. And so this is 25 years ago, and they go to previous studies that, of course, were affected by things that you've taken care of when you did your analysis. And so it's not so simple to pick out one variation and then go by that and then claim that that is still applicable to retrospective analyses 25 years later. So I think we're all on board. I think Harry, who at least in his paper doesn't differ 25 years ago from what Ghulam was just asking. I think they both had the same opinion at that point, and it was fair enough. Their work was probably done pretty well, but things change, and the understanding of how you do these analyses, because it is so complicated, I think that has changed a lot, particularly in systematic reviews. Right. So I think this panel is on board, and I think our audience, mostly from the questions or the comments I see, that I think they're clearly on board. If I may, I'd like to ask a question, and that's for both of you, from Bronte Stone in the audience. Does data exist on changes with time on any correlates of total sperm numbers, for example, testis size, primordial germ cell numbers, spermatogonial stem cells, testis blood supply, or testis histology? So
you know, if you want to do, the question, Shanna, I assume is if you want to do a time trend meta-analysis on other outcomes, on other parameters. So again, I think that, and again, as a scientist, my view is to be critical. I'm glad with any criticism, and I think that, you know, we are the first critics of our own research, and we look for issues all the time. And just to mention, because someone asked about the abstinence time, so we also accounted for the abstinence time reported in the study, etc., etc. Now, the problem, if you want to do a trend meta-analysis for other parameters, you have to have a valid measure, that the measurement did not change over time, and that you have enough data. That's the issue. The sperm concentration is such a wonderful measure because you do have, you know, this abundance of data. But if you want to take, you know, a testis pathology, how many studies do we have that we can do this kind of things? And, you know, it's so complicated. So again, I'm open to, and sometimes you can find the leftovers of studies something interesting and new to study. So you know, again, we have, you know.
Well, I think he's criticizing. I think he's asking.
No, I'm saying that in a meta-analysis from my experience, and I'm calling, you know, younger and older researchers. Sometimes you can find something that no one has looked for. Okay, the data is there, but no one compared, you know, males and females, even though the data was published. I'm just saying as an example. And then you can do a study on something that no one has looked for. So if you ask the right question, then you can get the right data. So if someone, you know, like Shanna started with the anogenital distance, etc. So I'm just saying, I'm not saying no. If someone can find, you know, with morphology or motility or other parameters and find a way to systematically see, is there a difference over time or over geographic place? That's wonderful. I'm not saying it's impossible, I'm just speaking about the challenges and limitations in doing that.
Sure. Allan and Harry.
Yes, there was just a question about, and I apologize, let me just get the person's name. Dr. Ronaldo DeMello asked, wondering if the chemical studies affect sperm motility and morphology. You know, again, so if anybody wants to tackle other than sperm counts, are motility and morphology affected?
There are many studies showing that specific chemicals affect these other parameters. But like Hagai said, we can't do trend studies on these things because of the changes in method of measuring morphology and motility. But if you Google, if you want to know, you can Google EDC and sperm motility, and you'll see a lot of studies. What they're worth and how you evaluate them, that's another thing. I can't talk about that right now.
So
I just wanted to comment because Shanna said earlier about the contraception. Just to say, the contraceptive pills in another issue is that it also affects the environment, and maybe Shanna or other can elaborate on the studies on the impact on different animals and the ecosystem. Yeah. So again, I'm just saying that, and that's okay, that's life, but we live in an experiment. We are using chemicals that were never used, and we expose humans and animals and plants to these chemicals, and some of them would affect reproduction. So it's our obligation to study that in a scientific way. That's what we have to do, and not to assume that it's okay, because we have clear evidence that at least some of these chemicals have long-lasting effects on reproduction. And with that, I would also say, and unfortunately, science is not really going to this direction. Exactly as Rod said earlier, we need both animal studies and clinical trials, experimental studies, and epidemiological studies. We need it all, and we need to communicate and to see, okay, I found something as an epidemiologist, I found something here, and someone else would find. I saw that there was a question about the impact of the mRNA vaccine on sperm. If we will not study, we would never know. We have to conduct such studies.
So I just want, while I still have a minute to say this, I just want to support Rod's study, which nobody talked about, on the Tylenol, on the APAP, the paracetamol, right? And I've been part of a group. We have 99 signers. Rod is a signer of this consensus statement that we're putting out. It should be published in 2 weeks. It's a consensus statement saying that we have enough evidence on the harms of prenatal exposure to Tylenol, paracetamol, to ask not for absence of use, but for women to ask their physician before they use these chemicals, and to use, as Rod said, the shortest time at the lowest dose. So I think there's good agreement on that, and there are many, many outcomes associated with prenatal exposure to paracetamol, not just reproductive. So I just want to put in a plug for that.
Yeah.
On the same note, just to say, Woody Allen said that my brain is my second favorite organ. So specifically the brain is really affected, and we published a meta-analysis on paracetamol pregnancy and autistic spectrum disorder and ADHD, and we found some associations. So again, not to say not to use, we spoke about it, but it's our obligation to do research and to better understand.
Allan, is there anything?
Shanna, you ended your talk with a very interesting proposition about what we need to do to reduce our chemical exposure in the world. And I have no problem with what you proposed, but I wonder if it presents us with a conundrum in that you said that so few chemicals have been tested for their reproductive effects. But I wonder if we've got the tools to properly test the remainder, if you like. And I mean, it's an enormous task that you've set the world to do that. So how would we make the first steps in order to do that?
So that's a great question. I would say we have to consider those that are out there and those that are now entering the workplace, our lives, stream of commerce. And let me start with the second, because that's a relatively smaller number. So just give you an example. You're in Scotland, so I don't know about the EU, but for you, but in the EU, there are 1,100 chemicals banned from personal care products as a result of testing. In the US, there are 11. Okay, so there's something going on in the EU, which is not going on in the rest of the world. And that is that there's REACH. And that is the idea that a chemical has to be tested for safety before it's put into the marketplace. So that's a really important first step, dealing with new chemicals. Now, as far as the old chemicals, that's a problem because they were all grandfathered in, right? Under TSCA, they were just grandfathered in. If they've been here a long time, they're not doing a lot of harm, let them in. That was the attitude, okay? So what we can do to speed things up, I think, is we can do functional assays. So there are assays that look at the estrogenic activity of a product, of chemical, or the anti-androgenic activity. So you can look for the hormonal activity of a product. Even if you haven't done the animal study and the human study, you have an in vitro study that can tell you something about its potential to alter the body's hormones. And that's what we have to look for. What can mess up our hormones? Because what's much more important for reproduction than our hormones, right?
I didn't realize we had in vitro tests that were that sensitive and accepted to do all that. So yeah, it's a much more achievable goal if we have those tools.
Ellen, if I just may, it starts on top of what Shanna said by recognizing the problem. We saw that when that's what the silent pandemic. I mean, in general, detoxification. When we had a pandemic, and I called for 20 years to be prepared for infectious disease pandemic. That was, my position in Israel. But and the answer was, and the call was not answered. So, but when there was a pandemic, a vaccine was developed. If we recognize, as the United Nations tried to claim, detoxification could be a life and death matter for mankind, then we can actually start and find the solution. And there are all kinds of rapid tests that could be developed to test at the same time many different chemicals, etc., etc. But we didn't really try it so far, not in a moonshot kind of thinking.
Guy, thank you. We really appreciate all the comments. We need to wrap up. I'd like to just make a few statements. We'd like to thank Zymot for sponsoring the session and all who took part in this webinar. My co-host, Dr. Jacques Cohen, Professor Allan Pacey, and speakers Professor Rod Mitchell, Professor Hagai Levine, and Professor Shanna Swan. Thank you for the organizing committee of this initiative, Peter Nagy, Giles Palmer, Thomas Elliott, Marianne Sevates, I hope I got that right, Jacques Cohen, and Shaista Sudrodin. Thank you to everybody with that. Okay, I'll go ahead with this wrap up.
So Jacques called me a wizard earlier. So I have a wizard wand here to wrap up the session. Just to remind everyone that the next session is on the 14th of September with the 3rd episode of RBM Online, taking a hard look at reproduction, society and technology, and discussing elective egg freezing and women's emancipation. But for this session, that's it. It's been great. Wherever you are in the world, have a great rest of your day, and we'll see you next week. Goodbye.
Take care. See you.
Thanks.